In question number 10, we are told that the figure shows orbit of the Earth and the orbit of the comet around the Sun. So something that we really ought to remember is that the comet has an elliptical and very elongated orbit, and it's usually around the Sun, while the planet orbit around the Sun, but its orbit is not so much elongated or elliptical as shown on the diagram here. So we're going to answer various questions from space physics, and this is going to be the orbit of the planet, and the one that is elongated B is the orbit of the comet. So also we need to have an idea how the comet move around its orbit, so which is going to be identified in the next question. So we're going to state that between A and B, A is the orbit of the planet, but B is the orbit of the comet. And how you identify that, you are looking at the elongation, which one has a large elliptical and which one has a small, and the Sun is quite squashed towards the end of the orbit of the comet, so that you had to put it in consideration. So we are supposed to say the Sun is not at the center for the comet, and the orbit is quite elongated or elliptical for the comet. So we need also to identify that as the comet moves around its orbit, the speed keeps on changing, whereby it's moving slowly when it's very far from the Sun, but when it's close to the Sun here, it's going to be moving very, very fast in that case. So speed keeps on changing because energy is being transferred from potential energy to kinetic energy. We're supposed to describe and explain how the motion of the comet changes. In this particular question, we are supposed to say the comet travels fastest when it's close to the Sun, because it will be having high kinetic energy, because all the potential energy will be converted to kinetic energy. And when it's very far away from the Sun, it means that it's going to travel slowly, because all its potential kinetic energy will be converted to potential energy, the process of its movement. Something else you need to remember in space physics is the definition of what we mean by the term 1 light year. 1 light year is the distance light travels in 1 year. So the definition we are supposed to write is this one here, and then to determine the distance in meters, for this particular 6.6 times 10 raised power negative 6 years, then it means we have to first to know what is the distance in meters for 1 light year, and that's going to be speed is equals to this distance is speed times time, and in this case our speed is 3 times 10 raised power 8, which is the speed of light, and then times 365 days times 24 hours over day times 3600, so that we can be able to get what 1 light year is, and that translates to 9.5 to power 15 meters. But now we need to convert now 6.6 times 10 raised power negative 6 to meters, and to work out that is just cross multiplication, and if you work it out, you'll get your final answer being equivalent to 6.27 times 10 raised power 10 meters. So basically that's what you were expected to do in this particular question of space physics.